the equation that reads x minus 1 quantity squared over 9 minus the quantity of y plus 4 squared over 16 equals 1. So I want us to include center, slope of the asymptotes. Oh, sorry. Center, asymptotes, asymptotes. Foci and vertices. So to start, I have to first decide, is this a horizontal parabola, horizontal hyperbola, or a vertical hyperbola? And how do you know? Good. So this is a horizontal hyperbola because the x is positive. Had the y been positive and the x negative, then it'd be a vertical hyperbola. So this is horizontal because the x is positive. And now what we're going to do is start listing out all of our different things. So I want us to include the center. So just to remember, the equation of a horizontal hyperbola is the quantity of x minus h squared over a squared minus the quantity of y minus k squared over b squared equals 1. And the center, if we remember, is h comma k. So our center for this hyperbola is going to be the point 1, negative 4. Is anybody confused with how I got a positive 1 and negative 4? Are we all good with that? Okay, so let's keep going. Just to help us out with other things that I'm asking, do we agree that a squared is 9 and b squared is 16? Is it okay that the a is smaller than the b? Is that okay? Yeah. In what conic is the a always bigger than the b? In which conic? Violet? An ellipse. In an ellipse, the a is always bigger than the b. In a hyperbola, it doesn't matter. Sometimes a is bigger, sometimes b is bigger. What distinguishes or determines what kind of hyperbola it is which one is positive. If x is positive, it's horizontal. If y is positive, then it's vertical. But it doesn't necessarily mean that a has to be bigger than b. A is just always under whatever is positive. Are we okay with that? Because I know that's easy to mix up with the ellipse. All right, since a squared is 9, do we all agree a is 3 and b is 4? Okay, the transversal axis is vertical. I'm sorry, not vertical, horizontal. So when I say the transversal axis is horizontal, it just means that my hyperbola is horizontal. That's all it means. But now if I want the transversal axis length, and I should have put this as something that I wanted, it's going to be 2a. Well, if a is 3, do we all agree the transversal axis length has to be 6? Does anybody remember what this represents, the 6 units? Anybody remember? Okay, so what the transversal axis length is going to represent the length from one vertex to the other. So one vertex to the other vertex is going to be 6 units. I'm now going to identify the slope of the asymptotes. And now if you guys remember, the slope of the asymptotes for a horizontal hyperbola is going to be plus minus b over a. So this is going to be plus minus 4 over 3. Right, I'm going to start my graph. I'm not done doing some algebraic work, but I do have enough to at least start the graph. Now, if you guys remember, we said the center point is actually where the two asymptotes intersect each other. So when I have my center is the point 1, negative 4, I'm going to go to the right 1 and down 4. So we go to the right 1, down 4. 1, 2. This is my center. Now what we want to do from that center point, we're going to create our asymptotes. So my first asymptote has a slope of positive 4 over 3. What does that mean? It means I'm going to go up 4, right? Remember our slope is rise over run. So I'm going to go up 4, 1, 2, 3, 4, to the right 3, 1, 2, 3. Let's keep going. Up 4 again, 1, 2, 3, 4, to the right 3, 1, 2, 3. Then we're going to go down 4 to the left 3. 1, 2, 3, 4, left 3, 1, 2, 3. Go one more time, down 4, 1, 2, 3, 4. To the right 3. 1, 2, 3. How should I draw this? How should I connect the points of this asymptote with what kind of line should I say? What kind of line should all asymptotes be drawn as? Ariana? A dashed line. All asymptotes must be drawn as a dashed line because it's not really part of the graph. It's sort of just guiding the graph where it can and cannot go. That's just one asymptote. How many asymptotes do we have? 2 asymptotes. So the other asymptote has the same starting point, the center right here. But now this time, my slope is negative 4 over 3. So what does that mean? I'm going to go down 4, 1, 2, 3, 4, to the right 3, 1, 2, 3. Let's go down 4 again, 1, 2, 3, 4, to the right 3. And then we're going to go up 4, 1, 2, 3, 4, to the left 3. Let's go one more time, up 4, 1, 2, 3, 4, to the right 3. And once again, I connect the points with a dashed line. If on the test you draw an asymptote with a solid line, I'm going to have to take points off because a solid line means it is part of the visual graph that we're looking at, and it's not. Like I said, it's sort of just invisible barriers of guiding where the graph can and cannot cross. That's all the asymptote is. And who remembers the asymptote is heavily affected by what? For most scenarios, the asymptote is heavily affected by the domain that it's going to be bigger for us moving next chapter, not so much this chapter. For this chapter, we really just need to remember the formula for the slope of the asymptotes. Okay, let's keep going now. So here we have our center. We plotted that. We plotted our asymptotes. Now what we want to do is we want to plot the vertices. Now the vertices, the transversal length is 6. What that means from one vertex to the other is 6, but it's also from the center point 3 on each side. So what does that mean for us? From the center, and because it's a horizontal asymptote, I'm not going to go up, down. So from that center, I'm going to go left 3, 1, 2, 3, and to the right 3, 1, 2, 3. So that's 6 units in total from one vertex to the other, but they're also the midpoint or the halfway point will be the center point between those two vertices. So I've asked for the coordinates of the vertices. So the vertices, we have two vertices. And so the one point is going to be -2, -4. And the other vertex is going to be +4, -4. So those are the two vertices. And then once you have the vertices and you know it's a horizontal asymptote, what you do is you're gonna, you know it's a horizontal hyperbola. What you're going to do is you're going to draw this curve and sort of use the asymptotes to help guide us. So this is not gonna be 100% accurate, but it's an idea. So we're gonna just sort of get close to those asymptotes, but not cross it. And then the other one's opening to the right. So again, we get close to the asymptotes, but we don't cross it. So it looks something like that. And the curves are not going to be 100% accurate. It's just an idea of getting close to those asymptotes. There's one last thing I asked for that we have not put yet. What's the last thing I asked for that we haven't put? Hi, Anna. The foci. Now, there's no formula to find the coordinates of the foci, but there is one to find the length, the focal length. So if you guys remember, the formula for the focal length in a hyperbola is going to be C equals the square root of A squared plus B squared. So we're going to have C is equal to the square root of, what was my A and my B? 9 plus 16. So C is equal to the square root of 25, which is 5. Now, what this 5 represents is from the center to the foci, or from the foci to the center is 5 units. And so we go back to the center point, and I'm going to go from the center, I'm going to add 5 units to the left. 1, 2, 3, 4, 5. And from the center point, I'm going to add 5 units to the right. 1, 2, 3, 4, 5. So this is like F1, F2. And so I want the coordinates for the foci. So the first point is going to be -4, -4. And the second coordinate will be +6, -4. And there's our graph and everything I asked for. All right, next one. Find the center foci slope of the asymptote and vertices of y squared minus 2x squared plus 6y plus 4x minus 9 equals 0. Okay. As of right now, is this a good format? No, so I have to make it into a good format. How am I going to make this into a good format? What should I do? What is that algebraic process called? Complete the square. How many times am I going to complete the square? Twice, once for y, once for x, once for y. So what I'm going to do is I'm going to group together the like variables. So I'm going to group together y squared plus 6y plus, we always put a plus in between for now, negative 2x squared plus 4x equals 0. Can I complete the square if x squared or y squared has that leading coefficient? No. So do you guys see how x squared has that negative 2 as a leading coefficient? I'm not allowed to complete the square. Oh, sorry. What did I forget to do? Add the 9 over. Thank you. All right, so do we see how that x squared has a negative 2 leading coefficient? I can't complete the square with that leading coefficient. Who remembers what do we do to get rid of that leading coefficient? We treat it like a GCF. So it's not really taking it out. It's not really eliminating it. It's just taking it someplace else so I can complete the square. So the y's are good. Y squared plus 6y is good. But now I'm going to pull out a negative 2. And when I pull out that negative 2, I'm left with x squared minus 2x. And now I can complete the square. So half of 6 is 3. 3 squared is 9. So if I add 9 to the left, I have to add 9 to the right. Half of 2 is 1. 1 squared is 1. So in reality, I'm not really adding a positive 1 because isn't there a GCF of negative 2 on the outside? So I'm going to do negative 2 times 1, which is a negative 2 to the other side. And so now we complete the square. So we're going to have y plus 3 quantity squared. And do you guys see how I have this plus the negative 2? Isn't that plus the negative 2 the same as just minus 2 times the quantity of x minus 1 squared equals 18 minus 2 is 14. Oh, 16, not 14. Why do you think I decided instead of writing plus a negative 2 to just make it minus 2? Why do you think I did that? Yeah, well, it was actually not incorrect for us to do plus a negative, but what is this really just for us? That there's a what between the two parentheses? A minus sign, which means it can't be an ellipse, it must be what? A hyperbola. So that's why I chose to make the plus and negative a minus to make it exaggerate that minus, to make it very clear that that's a minus. So it is a hyperbola. Sorry, I wrote 1. This is a 16 here. Is this a good format? No, and hyperbola has to equal what number? 1. So I'm going to divide everything by 16. So now we're going to have the quantity of y plus 3 squared over 16 minus, we can simplify this, the quantity of x minus 1 squared over 8 equals 1. Now, is this in a good format? Yeah, it's perfect. So now I have to ask myself, is this a horizontal or vertical hyperbola? Horizontal or vertical, and how do you know? Good, how do you know? You got it, because the y is positive. So we know this is vertical because the y is positive, yes. Correct, that would make it a hyperbola. Yep. All right, let's keep going here. So because we just declared this as a vertical hyperbola, I'm going to say the transversal axis is vertical. And that's just how we say that it's a vertical hyperbola, really. The fancy way of saying it's a vertical hyperbola. Transversal axis is vertical. If the transversal axis is vertical, that means a squared is 16 and b squared is 8. which means A is 4 and B is 2 root 2. Okay, let's see what I was asking for. Find the center. You tell me, what's the center here? What's the center? Pilot. You got it, negative 3, 1. And then I'm asking for, I said find the center, find the foci. Before I find the foci, I want to find the vertices. What do you think I should go back and find that will help me find the vertices, Amanda? Sure.
If the center is H.
Oh, sorry, guys. I didn't even catch that. Yes, your center is not negative 3, 1. Sorry, this is in the format of, good catch, Amanda. This is y minus k squared plus x minus h squared equals 1. So our k, because the y is first, our k is first. So this is going to be 1 comma negative 3. Great catch. Okay. What should I find that will help me identify the vertices? Ariana? Good. The length of the transversal axis. So the transversal axis is vertical. The length of the transversal axis is 2a, which brings us to 8. What does that mean? I can't hear you. Good. It means the vertices are 8 units apart. Now, are the vertices left, right of each other or up, down of each other? How do you know up, down, not left, right? Good. We know it's up, down from each other. It's vertical from each other because it's a vertical hyperbola. And now it's 8 units apart. What's the middle point between the two vertices? Violet? The center. So without me actually graphing, can I find the vertices? Absolutely. I'm going to go to the center and I'm going to add 4 units up and 4 units down. But to which coordinate? The x coordinate or the y coordinate? Good. Y. The y. Good. We're going to add it to the y coordinates because it's a vertical hyperbola. So what I'm going to do is I'm going to have the point 1 comma negative 3 plus 4 and 1 comma negative 3 minus 4. So I went 4 units up from the y coordinate of the center and 4 units down from the y coordinate of the center. So now the vertices are going to be the coordinates 1 comma 1 and 1 comma negative 7. So we found our center and we found our vertices. So even though I didn't ask for the transversal axis length, was it important for us to know that? Yeah, that was the way we found the vertices, is using that transversal axis length. All right, let's keep going. So I found the center. I found the vertices. Let's talk about the slope of the asymptotes now. Now, for a horizontal hyperbola, the formula for the slope of the asymptote was plus minus b over a. For a vertical hyperbola, it's not plus minus b over a, it's plus minus a over b. So what does this mean here? This means, what did we say a was? A was 4, and b was 2 root 2. Can I leave it like this? No, there's a bunch of reasons I can't leave it like this. Quicker reason is I can simplify the 2 and the 4. So I get 2 over the square root of 2. Bigger reason is I can't leave a radical in the denominator. So I'm going to rationalize. So the slope of the asymptote is going to be 2 root 2 over 2. And don't those 2's cancel? Sorry, plus minus. This should all be plus minus. So this is going to be plus minus the square root of 2 is the slope of the asymptotes. All right, next one. What was the last thing I asked us to find? Foci. So we're going to use the focal length, which is the same formula for both horizontal and vertical. So that's going to be C is equal to the square root of A squared plus B squared. So C is equal to the square root of 16 plus 8. So C is equal to the square root of 24. So that's going to break down into 2 root 6, right? 4 and 6. Yep, 2 root 6. Was I asking for the focal length? No, I was actually asking for the coordinates of the foci. So now we have to remember, guys, remember this if this is a vertical hyperbola, the curves eat the foci. So the foci are always inside the curves. So what does that mean? I'm going to go to my center point and I'm going to add that 2 root 6 to the x coordinate or to the y coordinate? To the y coordinate. So now the foci will be my center point, which is 1, -3, but it's going to be 1, -3 plus 2 root 6. And then 1 comma -3 minus 2 root 6. And we can't simplify that, so you leave it just like that. Okay, the last thing we're going to talk about today is one more type of hyperbola. So we spoke about a horizontal hyperbola, we spoke about a vertical hyperbola. This next type of hyperbola is called a rectangular hyperbola. And this is the last new conic that we're learning. And the parent graph for a rectangular hyperbola is y equals a over x. And what that looks like is a curve in quadrant 1 and a curve in quadrant 3. Or the other parent graph is y equals negative a over x. And when the a is negative, our two curves will not be in 1 and 3, they'll be in 2 and 4. Now, the equation of a rectangular hyperbola is going to be y is equal to a over x minus h plus k. Now, in our parent graph, do we agree there were two asymptotes here? There's an asymptote, a vertical asymptote at x equals 0, a horizontal, a vertical asymptote at x equals 0, a horizontal asymptote at y equals 0. So let's go back and write that. So asymptote for both of these. X equals 0, y equals 0. Okay, so here, our center point, which is going to be the point the two asymptotes cross, is going to be the point h comma k. And then once you get your center point, you're going to, for the asymptotes, we're going to have one asymptote, which is x equals h, and another asymptote will be y equals k. So it'll always be one vertical line and one horizontal line for your asymptotes. Okay, now to find the vertices, so to find the two vertices, what you're going to do is you're going to do plus minus the square root of the numerator. And then whatever that number is, move that number from the center point. This will all make sense once we actually do a problem. We ready to do a problem? Okay. I want us to graph xy equals 9. I didn't tell you what this is. So our options are a parabola. Is this a parabola? No, nothing squared, right? Not x, not y, right? Then it brings us to a circle. Is this a circle? No, I actually know it's not a circle. I know it's not an ellipse, and I know it's not a normal hyperbola. How do I know it's not a circle, ellipse, or even a normal hyperbola? But for all those, we need x squared and y squared, and we don't have either of those. So what is the only one that we've been talking about that has nothing squared? A rectangular hyperbola. And I know this isn't a line. A line is also a conic too.
I know this isn't a line. I know this isn't a line because it's X and Y being multiplied together. And a line wouldn't X and Y be added together or subtracted, right? So because it's multiplication and there's no exponent on the X and Y, I know this has to be a rectangular hyperbola. Any questions on how I've identified this as a rectangular hyperbola? Okay, so now what I want to do is I want to make it look like this. Its standard form. And its standard form is basically just saying get y by itself. That's how we make it look in standard form, get y by itself. So if I'm going to get y by itself, what does that mean? I have to divide by x. So now the equation of this rectangular hyperbola in standard form is y equals 9 over x. And this should fit the format of y equals a over x minus h plus k. Are we good so far? Do we agree I can easily put minus 0 plus 0 if I wanted to? Okay, if you want to, go ahead and do that. So now, because my A is positive, I'm in quadrants. Because A is positive, we're going to be in quadrants 1 and 3. So the first thing I want to do is identify my center point. What's my center point? Isn't our center h comma k always? And so this is 0, 0, which is the origin. Is it okay for the center to be the origin? Absolutely, that's perfectly fine. Now what I want is the equation of the asymptotes. So now the equation of the asymptotes is going to be x equals h and y equals k. So we're going to have x equals 0 and y equals 0. All right, I'm going to get my diagram going. Okay, so now we have our asymptotes. We have the center, which is the 0, 0. Now what I want to do, I know I'm going in quadrant 1 and quadrant 3 since it's positive, but now I need to find the vertices. The way you're going to find the vertices is you're going to take your A, so A equals 9, and I'm going to take the square root of 9. I'm going to take plus minus the square root of 9, which is plus minus 3. So we're going to say move this amount in left slash right and up slash down. And I'll show you what I mean by that. From the center. Okay, so what does this mean? This means my center is 0, 0. And I know I have to be in quadrant 1 and in quadrant 3, right? So from this point, I'm going to move to be in quadrant 1. I'm going to move 3 to the right and 3 up. Why would I move 3 to the right and 3 up instead of 3 down? Because if I move 3 to the right and 3 down, would I be in quadrant 1 anymore? No, I'd be in quadrant 4. So you move in that direction. That's what I mean, left, right, up, and up, down. So we're going to move 3 to the right, 1, 2, 3, and 3 up, 1, 2, 3. So here's my first vertex. And then you just draw your curve going towards the asymptotes.
And now my other curve has to be in quadrant 3. So from the center point to land me in quadrant 3, which direction am I moving? From the center. You got it. 3 to the left and 3 down. So then my vertices are will be the points 3, 3, and -3, -3. Hello, Mr. Colodi. All right, one more problem for today, and then we will call it a day.
I'm still working you guys at 10:21. Goodness, come on.
I know, I'm evil.
Hey,
The worst. All right. Okay, there should be a negative out front there. Is this a good format? No. But just to start off, how do I know this is a rectangular hyperbola and not anything else? Amanda? Nothing squared, exactly. And how do I know that this is not a line? Because a line can come up. We should all be proficient in lines. Violet? Good. There's no plus or minus between the x and y. They're being multiplied, which tells us a rectangular hyperbola. So now in order to put this in standard form, I need to get the y by itself. So I'm going to divide by the negation of x plus 1. So that cancels here. So now I'm going to have a y minus 3 equals, is it okay if I just assign that negative to the numerator or to the outside of the fraction? Is that good? Yeah, that's absolutely fine. So I'm going to say the negation of 4 over x plus 1. And my last step will be to add that 3 on both sides. So now we're going to have y is equal to the negation of 4 over x plus 1 plus 3. And now this is beautiful because it absolutely fits the format of a over x minus h plus k. I'm going to put a little star here because negative, what quadrants are we going in? Yep. So I'm going to say the quad 1 and 4 or the shifted quadrants 1 and 4. And you'll know what I mean in a minute. So quad 1 and 4, and I'm going to put shifted. And you'll see what I mean when I say shifted in a minute. So let's go here. Let's get this graph going. What's my center point? Violet. Our center point is, what did you say? Is it positive 1? Negative 1, 3. Perfect. So we're going to go negative 1 and then up 3. 1, 2, 3. And then my asymptotes, I'm going to have, so let's write this out. Center is negative 1, 3. And my asymptote, or asymptotes, 2 of them, is going to be a vertical line, x equals negative 1, and a horizontal line, y equals 3. So it's always right through the center point. Okay, so now that I have my asymptotes, my graph is going to be in quadrant 1 and quadrant, oh, why did I say 1? It's not quadrant 1. What quadrant is it? Shouldn't be quadrant 1. It should be 2 and 4. Sorry, guys. Should be quadrant 2 and quadrant 4. And now I said shifted.
So what do I mean when I say the shifted quadrant 2 and 4? Because it's based on my asymptotes, right? So wouldn't this be my shifted quadrant 2 and this be my shifted quadrant 4? So this is where my two graphs are going to go. Now, how am I going to find the vertices for these two curves?
You go to your A. A equals 4. So we're going to take plus or minus the square root of 4, which is plus or minus 2. What does that plus minus 2 mean? We're going to move left, right, 2. Oh, sorry. Left, right, 2 in my appropriate quadrants. So from the center, I'm going to move 2 to the right and 2 up. So it looks like that. And, oops, sorry. That's not right. Why is that not right? That puts me in quadrant what? 1. So from the center, I'm going to move 2 to the left, 1, 2, and 2 up. There we go. That's how I get in quadrant 2. And then from my center, I'm going to move 2 to the left and 2 down. So it looks something like that. So my vertices are going to be the points -3, 5, and is that 1, 1? Does that sound right? Yeah, we're good? Okay, we are done for today.